Hello again, my students. Today we are within the section B of this paper, Unit 2, October 2023. Okay, in section B, you have a question about the sodium hydroxide. Sodium hydroxide is alkaline solution, and he's asking you write an ionic equation for the neutralization reaction between aqueous sodium hydroxide and hydrochloric acid. The state symbols are not required. So to write the equation, it's very easy. Here you have sodium hydroxide, so we are talking about OH or hydroxide, and hydrochloric acid. What is left is the hydrogen ion, and we are talking about a neutralization reaction to form water. Okay, state what is meant by the standard enthalpy change of neutralization. So we have three important things that we shall focus on them. The standard means that we have standard conditions, enthalpy change of neutralization. So it is the energy released. You can write it is the energy released, since it is exothermic, when 1 mole of water is formed from the reaction of acid with an alkali at standard conditions, at standard temperature 25 degrees or 298 Kelvin and 1 atm or 100 kilopascal atmospheric pressure. That's important things, or these are the important things in the definition. Students carried out an investigation to determine the enthalpy change of neutralization of aqueous sodium hydroxide by the hydrochloric acid. The method, you shall separate 25 cubic centimeters samples. So he gave you the volume. As you can see, he gave you the volume there, and that's the concentration of sodium hydroxide, and 0.80 mole per cubic decimeter. That's also the concentration of the acid were left to reach room temperature. After 2 minutes, the solution were mixed in a copper calorimeter, and the temperature was noted at 30 seconds intervals. Use the graph shown to determine the maximum temperature change, delta T, and this experiment. You shall use the ruler there. So keep in your mind that you shall have a ruler in this paper. Why? Because in the graph, he gave you the graph like that. As you can see there, we can draw the two best fit lines by a ruler. Okay, you can draw best fit like that. It's not passed through the point. Okay, so you can draw line like that, and then another line best fit like that. And he told you that in the experiment, he told you where it is added was noted at 30 seconds. So where is 30 seconds? After 2 minutes, the time is 2 minutes. So you should return back to the graph, the figure. And where is the 2 minutes? In the 2 minutes, we are talking about what? About 120 seconds, since each minute is where you will attach the line. That's what is known as extrapolation to the curve. And you will see that the temperature is around 20, how much? Here we have a 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one is 0.1. So we have 22.1, 2, 3, 4, 5, 6. So 22.6 is the T1. And here it is a 26.4 maybe, or it's a 26.8. It's around like that. So you can find the answer by the calculator, and you will see that it is how much? It is 26.8 minus 22 point, it is 22, sorry, 0.1234. It's a 22.4, not 0.6. So it's a 22.8 minus 22.4. That equals what? It is 4.2 Celsius. Okay, that's how you can substitute. Now, to calculate is asking you to calculate the enthalpy change of neutralization using your answer to A and B. I give the sign of the units with your answer. Assume that no energy is used to heat the container, and the specific heat capacity is 4.2, and the densities of the solution of NaOH and HCl is 1 gram per. This assumption is very important, since here you can assume that the mass is 50. So to calculate it, it is 50 grams, or you can calculate it in kilograms, it depends. So the energy that's transferred equals the mass of the solution times 4.2, which is given, times delta T, which is 4.2 or 4.4. So we can use it as 4.4. Now the answer is 50 times 4.2 times 4.4. That equals on the calculator how much? It is 924 joules. Okay, this equals 0.924 kilojoules. Okay, what's the next? Explain how, if at all, the enthalpy change of a neutralization obtained in BI would differ if the heat of the capacity of the calorimeter was included in the calculations. As you can see there, if it is included in the calculations, okay, this will show that the calculation not taking in the account, and this increase since the calorimeter, and this will make it more exothermic. Okay, it will be more exothermic because the heat capacity would be greater. Okay, if the heat capacity is greater, this means that it becomes more exothermic. The delta H of neutralization, it becomes more exothermic. This means that what we neglect, what we canceled in our calculation was re-added again, and this will elevate the exothermic process. Aqueous sodium hydroxide reacts with 1 bromopropane to produce propane 1-ol. Say the type of the mechanism of the reaction. It's clear that it is a nucleophilic substitution reaction. Don't worry about the abbreviations, because the abbreviations used there, and you shall follow up what I was saying in the explanation. Don't write abbreviations in your external exam. Complete the mechanism for this reaction. Include curly arrows. So he's asking you to include the curly arrows and the relevant. Since it's a primary one, the mechanism is SN2 mechanism. In SN2, first of all, you shall show the partial positive, the partial negative. That's the first mark. Then this one comes there. It will form the intermediate, which is this one. This is carbocation, and Br minus, that's the intermediate. Then that's the OH. Then the OH, which comes from the mechanism, will show the product, and this will goes to the CH3, CH2, CH2O, but you shall draw it in a displayed formula as you started. Okay, and both all hydrogens. Okay, what is next? Under different conditions, sodium hydroxide reacts with 1-bromopropane to form propene. So we are converted from halogenoalkane to alkene. This is what is known as elimination reaction. Suitable solvent is ethanol or any alcohol. That's everything for this question. Now, for question 19, the question is about some of the elements in group 7 of the periodic table. The mixture of halide salts are found in a brine solution extracted from oil and gas wells. Iodine, which is used as a dietary supplement, may be obtained from these mixtures. A brine solution containing 2.49 grams of mixture of potassium iodide and potassium chloride was analyzed. This is a mixture. The procedure is excess aqueous silver nitrate solution was added to the solution, complete to precipitate the halide ions. Excess aqueous ammonia was added to the mixture. The mixture was filtered, okay, and the solid was washed, dried, and weighed. The mass of the dried solid was, briefly, the solid there is AgI, because it's insoluble in dilute ammonia, and state the color of the solid. This will be yellow. It is this one. Now, calculate the percentage by mass of potassium iodide in the mixture. Give your answer to appropriate number of significant figures. First, we shall start from the mass of the bromide. Okay, here the mass is, let me open the calculator, where is that? Okay, the mass, it is, first of all, AgBr molecular mass. AgBr molecular mass equals, Ag is 107.9 plus what is known 120, that's the iodine, sorry, not bromine, it's iodine, AgI, so plus 126.9, okay, that's the molar mass. And you can divide, if you want to find the moles, you can divide the mass which is given, which is 0.162 over this. That's the molar mass of moles, is the mass over the molar mass, that's the moles. Okay, so it's mass over the molar mass, and this will give us answer of 6.899 0.995 times 10 to the power negative 4. Okay, now this is the same as what? As the potassium iodide. This is the same as the number of moles of potassium iodide, but the molar mass of potassium iodide is in a different story. Here we can take this number, which is the number of moles, is 6.8995 times 10 to the power negative 4 times the mass of potassium is 39.1 plus 126.9. So this will give us around 0.11453 grams. And then after that, you will divide this value, which is what? It is 0.11453 over the total mass of the 453 over the total mass, which is 2.49 times 100%. That's the original mass of both salts of the mixture, and this will give us 4.6%. Okay. Now, the next question, chlorine gas may be prepared by heating concentrated hydrochloric acid with solid manganese, like this equation. Show by referring to the oxidation number. That's a redox reaction. It's a redox reaction because, as you can see, you can calculate the oxidation number of each one. So that's positive 4, that's negative 2, that's positive 1, that's negative 1, that's positive 2, negative 1, 0, and here positive 1, negative 2. You can see what is changed is positive 4 manganese to positive 2, and you will see that chloride was changed to 0. So your answer shall include this term, since manganese changed from positive 4 to positive 2, and it is reduced, and chloride was changed from negative 1 to 0 in Cl2. This means that it is oxidized, so this means that the reaction is redox reaction. Okay? Now, the next one, iodine may be obtained by bubbling chlorine gas through the aqueous potassium iodide. When the reaction is completed, the hexane is added and the mixture shaken. 2 layers are formed. Say the color of each layer. For the aqueous layer, we are talking about, here he said that chlorine gas through the iodine may be obtained. So iodine, it's brown. It will be brown, yes. It will be yellow brown in the, that's the color of the iodine solution. Hexane layer, it will be violet or purple. Since the iodine is more soluble, and it will give the color of its vapor in the solution. Now, what's next? Explain why the iodine is more soluble in hexane than in water by considering the intermolecular forces in iodine, hexane, and water, and any intermolecular forces formed between the iodine and the solvent. details description of how intermolecular forces form are not required. Again, explain the iodine is more soluble in hexane than in water. Okay, here I shall mention the most important things there to answer the question. First of all, you shall mention that hexane is nonpolar, so the type of bonding between hexane molecules is London force. Second idea is water is a polar molecule and its hydrogen is bonded with electronegative oxygen. This means that it can form the hydrogen bond. When iodine is added to water, it is slightly soluble because the bonding between iodine and water, it's not enough to overcome the strong hydrogen bonding in water. And why it's soluble in hexane? Because the bond or the London force that is formed between iodine and hexane is stronger than the London force between hexane themselves and the iodine themselves molecule. That's why it is more polar. More and more details are required also for mentioning what the London force was mentioned, and they also iodine can form the hydrogen bond. So the main points which they are needed for this equation, again, you shall say hydrogen bond present in water, hexane has the London dispersion force only and can do the hydrogen bond, iodine can do the hydrogen bond. That's why the hydrogen and the iodine and hexane, they are soluble because both they have the same number bonding, and the London force between iodine and hexane is more or stronger than the intermolecular bonds between hexane or iodine molecules themselves. And you can say that the iodine can do hydrogen bond with water. That's it. All these features, they can be used in your answer. This question is about the carbon dioxide. The carbonate ion may be identified by their reaction with the aqueous acid, produce carbon dioxide. Give the ionic equation for the reaction, include state simples. Here we have carbonate, so it's CO3 negative 2 plus 2H plus. This will give us CO2 gas plus H2O molecule. That's liquid, that's gas, that's AQ, and that's AQ. Oh, sorry, wait. Carbonate ion, it is. Now, the lime water is an aqueous solution, okay? The lime water is an aqueous solution. We can write this equation in a different way, like that. You can write you can write CO3, for example, CO3 positive or negative 2. It is negative. Okay. It will be negative 2 plus H3O positive. So this will give you what? The CO2 plus H2O. But to balance the equation, you need to balance it. It's a 3H2O, and this is multiplied by 2. Another way of writing the equation. Both are correct, but in AS level, we don't deal with the hydronium ion a lot. Okay. Lime water is an aqueous solution calcium hydroxide, can be used to test for the presence of the gaseous carbon dioxide. State what would be seen when carbon dioxide is bubbled through lime water. The lime water turns milky. Lime water turns milky. Okay. Now students, determine the solubility of calcium hydroxide in water by the titration with hydrochloric acid. The equation for the reaction is shown as follows. This is the equation. Procedure is calcium hydroxide powder was added to the distilled water, and the mixture was stirred until the more solid was dissolved. The excess solid was filtered off to leave the saturated solution. Then 25 portions of the solution were titrated, and you shall know that the calcium hydroxide there is our solution, and he gave you the volume. Here, that's the volume. And of this solution were titrated, 0.05 of hydrochloric acid is with phenolphthalein as indicator until two concordant titer were obtained. The mean titer is or was 18.95. Calculate the concentration of saturated solution in grams per cubic decimeter. To calculate the concentration of the saturated solution in grams per cubic decimeter, what is needed is to start within the concentration and the mean titer volume. So the volume of the mean titer, it is titrated with 0.05 hydrochloric acid. So we can find the moles of the titrant. It is moles of HCl. That equals 18.95 over 1000 times the concentration, which is 0.05. This will give us 9.475 times 10 to the power negative 4 moles. If you return back to the equation, you will find the ratio is calcium hydroxide. Okay, so it is 2 to 1. So we shall divide the moles. So the moles of CaOH by 2. This will give us the answer 9.475 times 10 to the power negative 4 over 2. And this will give us 4.7375 times 10 to the power negative 4 moles. Okay, and then he's asking you, okay, so we have 17 times 2 plus 40 times 1. So you can find the molar mass of this. So the molar mass of this can be used within the number of moles, which is 47375 times 10 to the power negative 4 times the molar mass, which is 40.1 plus, because both they are 17, so it's plus 34. That equals how much? The 3.5149 times 10 to the power negative 2 grams. That's present in a 25, but okay, that's the grams. He's asking you grams per cubic decimeter, so that's the grams. Now you can find this as over volume. So if you divide this over 25 times 10 to the power negative 3, this will give you how much? It's 1.4 grams per cubic decimeter. That's the answer. Okay. And that's what is needed in the question. So let me repeat the steps. Moles of HCl by molar ratio, we find the calcium hydroxide moles. Then we multiply it by the molar mass of calcium hydroxide. And then we multiply, or we divide it over the volume of the, which is used in the equation. Now, students use the same procedure to determine the solubility of strontium hydroxide. Explain whether or not the mean titer value for strontium hydroxide will differ from. It will be larger since strontium hydroxide is more soluble. So it will be what? More. The titer mean, he's asking you if the titer mean, it will becomes larger. Okay. Between 1960 and 2020, the amount of carbon dioxide in the atmosphere rose from 320 parts per million to 420 parts per million. The recent rapid increase in the atmospheric carbon dioxide is affecting the chemistry of seawater. Carbon dioxide dissolves in water to form the carbonic acid, and the carbonic acid dissociates in water according to the equilibrium shown, and explain in terms of the equilibrium the effect of increase in the atmospheric carbon dioxide on the acidity of seawater. It's clear, according to the Le Chatelier's principle, if some of the reagents was increased or the reactant increased, the equilibrium shifts to the right. So increasing the amount of carbon dioxide, this leads to the formation of H2CO3. So it will become more, and this will shift the equilibrium, to the right-hand side, and this will increase the concentration of hydrogen ion, and this will elevate the acidity of water. Clear? I think it's very clear. Okay, that's everything about this section. Wait us for more details for section C. Thank you for good listening. That's me, Bishr Samhan, your chemistry teacher on the platform.